Hi, in this video, we are going to look at how we go about factorizing quadratics with higher exponents. When we looked at the rules of exponents, Rule 5 showed us that when you have an exponent inside of the bracket and an exponent outside of the bracket, we multiply the exponents together. So if, for example, we had x inside the bracket and an exponent of 2 outside, remember that x is actually x to the 1. 1 multiplied by 2 gives us 2. So we get x squared. Let's say we had x squared inside of the bracket and an exponent of 2 outside. 2 multiplied by 2 is 4. So we get x to the power of 4. What happens if we have x cubed with an exponent of 2 outside? 3 multiplied by 2 is 6. So we get x to the power of 6. From this, we can see that any term with an even exponent is technically a square. X squared is the square of x. X to the power of 4 is the square of x squared. And x to the power of 6 is the square of x cubed. To find the square of any term with an exponent, we simply double the exponent. X to the power of 1 becomes x to the power of 2. X squared becomes x to the power of 4. And x cubed becomes x to the power of 6. To find the square root of any term with an exponent, we divide the exponent by 2. X to the power of 6 becomes x to the power of 3. X to the power of 4 becomes x squared. And x squared becomes simply x. Now, we learned at the beginning of this section that a quadratic takes on the form ax squared plus bx plus c. But in more intricate examples, this is not always the case. The rule for quadratics actually states the exponent of the variable in one term must be double the exponent of the variable in another. So in this case, we have x squared and x. 2 is double 1. We could have ax to the power of 4 plus bx squared because 4 is double 2. We could even look at x to the power of 8 and x to the power of 4 because 8 is double the value of 4. So how do we factorize this? In exactly the same way we have factorized all of our previous expressions. Let's look at an example. Factorize the following expression: a to the power of 4 plus a squared minus 12. Here we have a to the power of 4 and we have a squared. 4 is double 2, so we know we are working with the quadratic. To factorize this, we need two brackets. So let's draw them in now. We have bracket 1 and we have bracket 2. A is the variable in the expression. In the first term, we have a to the power of 4. Let's square root it. So we're going to take 4 and divide by 2, which gives us a squared. This becomes the variable in the first term of each bracket. So over here we put an a squared, and over here we put an a squared. We only have one variable in our expression, which is a. So we know that the second term in each bracket will be a constant. Let's find these values. I want to put in the big X. Okay. Now in the expression, we have a to the power of 4, where the coefficient is 1, and the constant negative 12. Multiply these together. 1 multiplied by negative 12 gives us negative 12. Let's put this in up here. Our middle term has a coefficient of 1. Let's write this over here. Now we need to find factors of negative 12 that when added together give us positive 1. 12 is negative, so one factor will be negative as well. 1 is positive, which means the smaller factor will be negative. Let's look at the factors of negative 12. Negative 12 divided by negative 1 gives us positive 12. Negative 1 plus 12 gives us 11. Negative 12 divided by negative 2 gives us positive 6. Negative 2 plus 6 gives us positive 4. Negative 12 divided by negative 3 gives us positive 4. Negative 3 plus 4 gives us positive 1. This is the value we've been looking for. So we know that our factors are negative 3 and 4. Now, the first term in the quadratic expression has a coefficient of 1. So let's divide both factors by 1. We have negative 3 over 1 and 4 over 1. They're in simplest form, and we can leave them as is. The first fraction is negative 3 over 1. So our first bracket will be 1a squared, which is simply a squared, minus 3. Our second fraction is 4 over 1. So our second bracket is 1a squared plus 4. Let's tidy this up a little bit. Let's look at another example. Factorize the following expression: 12k to the power of 6 plus 2k cubed minus 10. Now, the first thing we have to do with any quadratic, regardless of its exponents, is we need to look for a common factor. We have 12k to the power of 6 plus 2k cubed minus 10. All three of these values are even, so we know that we can take out a common factor of 2. Let's do this now. We have 2, open bracket, 12 divided by 2 is 6, so we get 6k to the power of 6. 2 divided by 2 is 1, so we get plus 1k to the power of 3. Negative 10 divided by 2 is negative 5. Now inside the bracket, we have 6, 1, and negative 5. There are no more common factors. So now we can factorize this quadratic. Let's put in the big X. To start factorizing this, we need to draw in our two brackets. So over here, I'm going to say 2 outside of the bracket, open one bracket, and open the second bracket. Now, the exponent of the first term is 6. We have k to the power of 6. Let's square root this. So we're going to divide 6 by 2. 6 divided by 2 is 3. So we get k to the power of 3. So I'm going to put k to the power of 3 in over here, and k to the power of 3 over here. K is the only variable in the quadratic, so we know the second terms will be constants. Now we need to find the value of the constants as well as the value of possible coefficients. In the quadratic, the first term has a coefficient of 6, and we have a constant of negative 5. So we can say 6 multiplied by negative 5, and we get negative 30. Let's put this in up here. The coefficient of the middle term is 1, so let's put that over here. 30 is negative, which means one of its factors will be negative as well. 1 is positive, which means the smaller factor will be negative. Let's look at the factors of negative 30. Negative 30 divided by negative 1 gives us positive 30, which gives us 29. Negative 30 divided by negative 2 gives us positive 15. Negative 2 plus 15 gives us 13. Negative 30 divided by negative 3 gives us positive 10. Negative 3 plus 10 gives us 7. 30 is not divisible by 4, but it is divisible by 5. Let's divide it by negative 5, and we get positive 6. Negative 5 plus 6 gives us positive 1. This is the value we've been looking for. So we know that our factors are negative 5 and 6. Now, in the expression, the coefficient of the first term is 6. So we need to divide both factors by 6. Negative 5 over 6 and 6 over 6. Now we simplify. Negative 5 divided by 6 cannot be simplified, so we leave it as is. 6 over 6 can be simplified because remember, when you have a fraction with the numerator and the denominator is the same, it is equal to 1. So we can say 1 over 1. Now let's fill in our brackets. The first fraction is negative 5 over 6. 6 becomes the coefficient of k cubed, so we have 6k cubed minus 5. Our second bracket, edit, begin here. Our second fraction is 1 over 1, so we get 1k cubed, which we leave as k cubed, and then we have positive 1. And we have now factorized this expression. We will look at more examples like this in upcoming videos.